How useful is common sense in science? Short answer, not very. Our common sense, our intuition, is the sum total of our life experiences with the behaviors of the world around us. But it's limited to the familiar, the scale that we humans live in. Richard Dawkins, in a recent TED Talks on our existence in what he calls the middle world, quotes J.B.S. Haldane, who said, "The universe is not only queerer than we suppose, it is queerer than we can suppose." In a way, that's a statement of our limited imaginations. We aren't equipped with the mental tools to deal with the very, very large and the very, very small. Who can conceive directly of the size of the sun, then immediately conceive of the size of the sun in relation to our galaxy? You can't. It's just not a quantity we can wrap our brains around. Likewise, we can't imagine the size of an atom, or the distance between stars, or the age of the universe. We may stare into infinity, but we are unprepared to comprehend it. Here's a quick experiment. Close your eyes, no peeking. I want you to try visualizing 7 of something directly, without grouping the objects into subgroups. Imagine 7 apples on a table. Got it? Chances are, if you think you've done it, you're really just creating subgroups without realizing it. Most people are unable to directly conceive of any quantity larger than 6. You can open your eyes now. Let's take a quick look at why we shouldn't value common sense or intuition in matters of science or math. Let's start with some examples of statistics, something humans are really bad at. Suppose you're on a game show, and you're given the choice of 3 doors. Behind one door is a car, behind the others goats. The car and the goats were placed randomly behind the doors before the show. The rules of the game show are as follows. After you have chosen a door, the door remains closed for the time being. The game show host, Monty, who knows what is behind the doors, now has to open one of 2 remaining doors. And the door he opens must have a goat behind it. If both remaining doors have goats behind them, he chooses one randomly. After Monty opens a door with a goat, he will ask you to decide whether you want to stay with your first choice or to switch to the last remaining door. Imagine that you chose door 1, and the host opens door 3, which has a goat. He then asks you, do you want to switch to door number 2? Is it to your advantage to change your choice? The first time I read the problem, I was convinced that sticking with door 1 gave me the same chance of winning the car as switching. I'm not alone. When the problem was first presented in Parade magazine, it solicited angry letters from some really smart people. Why? Because the truth is that switching to door number 2 improves your odds substantially. Many of you are saying, no, he has it wrong. Common sense tells me that the car is behind one of the doors and the goat is behind the other. So the odds are 50-50. Nevertheless, the actual answer is that the odds are about 66-33 in favor of switching. I won't go into the proof. Check Wikipedia for the mathematical analysis and some graphical demonstration. Your common sense won't be of much help here. Here's another example. What are the odds of 2 people sharing the same birthday in a room containing 23 people? Most people would say it must be, 1 in 30. Surprisingly, to most people, it is only about 1 in 2. Again, your common sense isn't much help. Let's suppose you mix up some cornstarch in water. Then you drop a brick in it. Common sense will tell you that the behavior of fluids caused them to splash and move out of the way of the brick. In fact, when you try this, the brick hits as though the cornstarch and water were a solid surface. And then only after a long delay will it begin to sink. Cornstarch suspensions are an interesting phenomenon called non-Newtonian fluids. If you make up a large batch of starch-water suspension, you can actually walk on its surface so long as you move briskly. Going back to math, it can be proved that 0.9 repeating, that is 0.99999, is the same quantity as 1. Common sense tells us they're different quantities, but mathematically, it's clear they are the same. Light exists as both a wave and a particle. Water vapor is lighter than air. The Earth is round and orbits the Sun. All of these defy common sense, the phenomenological evidence of our senses. Scientists don't rely on common sense. When we approach a difficult problem, common sense is more likely to get in the way than to be a benefit. As Albert Einstein is reputed to have said, common sense is the collection of prejudices acquired by age 18. We have to learn to discard what common sense tells us in favor of empirical evidence and rational deduction. That brings me to the point of this video. Many of the arguments I have heard against the modern theory of evolution are largely about the counterintuitive conclusions it leads to. Many people struggle when presented with the idea that bacteria are related to humans, that we shared an ancestor with every one of the animals we see in the zoo. Some have trouble accepting the age of the Earth, that the Grand Canyon could have been formed by a gradual erosion and periodic uplift events over the last few million years. The literal biblical accounts are much easier to accept, and for good reason. They were written from a kind of common sense perspective. Pre-scientific peoples were trying to explain the world around them. Some of the conclusions they came up with were useful. Pork, shrimp, and oysters were probably a bad idea in an era of common foodborne illnesses and no refrigeration. But we replaced these ideas over time, as science and technology reveal more of the actual physical laws that govern our universe. So I think that one of the principal reasons so many non-scientists distrust the modern theory of evolution is that they are valuing their common sense view of the world over the empirical evidence and logical deduction. This leads to a lot of cognitive dissonance and denialism. Ultimately, it has led to a lot of anti-science feelings among the general public. And that's a shame, because common sense only takes you so far in your understanding and can lead to self-delusion and ignorance. For example, biologists do not recognize a division of micro and macro evolution. There's no evidence for it. There's no mechanism that limits genetic change over time. What the two categories really signify are the limits of human belief. We have experience with small changes within a group, but none of us has ever witnessed the level of changes that occur over hundreds of thousands of years. So we invent some non-existent division between believable and unbelievable and call them micro and macro evolution. It's strictly a defense mechanism to allow us to dismiss something we don't understand. I have sympathy for the people who do this. It's a very human response. It's just not science. So I hope the next time you hear someone say about a scientific topic, "Come on, that doesn't make any sense," you'll stop to think about how common sense limits our understanding of the natural world. Thanks for watching.